As an astrophysics professor who finds the possibilities of extraterrestrial life endlessly fascinating, I often get asked, if there are billions of stars out there, why haven't we found any signs of alien civilizations yet? This question was originally posed decades ago by physicist Enrico Fermi, and it remains an intriguing paradox. In this video, we'll thoroughly explore some proposed solutions, like the unsettling Great Filter theory. I'll do my best to break down these complex concepts about the probabilities of intelligent life in an easy-to-grasp way. Shall we begin? The Fermi Paradox. The question Fermi posed. The underlying query behind the Fermi Paradox goes like this. Given the immense size and age of our universe, if even a fraction of the billions of stars out there hosted advanced alien civilizations, wouldn't we have detected them by now? This paradox has intrigued generations of scientists and thinkers as we grapple with several tantalizing possibilities. Are we truly alone in the cosmos? Do solutions exist that could convincingly explain the eerie silence from the stars? Or do alien races deliberately conceal themselves from our detection? Possible solutions. Over the years, theorists have proposed multiple solutions that could potentially crack the Fermi paradox. Here are a few. Intelligent, communicative alien life is extremely rare or non-existent. We tend to assume alien life must be common, but perhaps the conditions needed to support advanced civilizations are far more unusual than we imagine. Factors like a stable host star, presence of particular elements, and long-term planetary climate stability may only coincide rarely. They exist, but are deliberately silent or beyond our detection capabilities. Alien races far more developed than humanity may be camouflaging signals from us, or communicating in ways our technology cannot perceive yet. Encryption methods impervious to our code-breaking abilities may be in use. There could be galactic civilizations hidden in plain sight. Evidence of alien visitations does exist, but has been suppressed. Some believe UFO sightings and phenomena like the Roswell incident in 1947 were hushed up by governments to avoid mass panic. But proof remains elusive. There are also theories that ancient sites like the Egyptian pyramids could have been constructed through extraterrestrial assistance. Ultimately, the silence from the depths of space continues to both tantalize and bewilder our imaginations. Perhaps we simply do not have enough data yet to decide between explanations. Next, we'll look at a famous equation that tries to quantify our odds, the Drake equation. Assessing the probability of alien life. In 1961, astronomer Frank Drake formulated an equation to statistically estimate the number of alien civilizations we could communicate with. It multiplies a string of factors like rate of star formation. How often do new stars capable of hosting planets form? Percentage of stars with planets. How many stars have orbiting planets? Number of planets suitable for life per system. On average, how many planets per system orbit in the habitable zone and meet chemical conditions for life? Fraction where life emerges. Of these habitable planets, on how many does life actually arise? Fraction that develop intelligence. What percentage of biospheres spawn species as smart as dolphins, octopuses, early hominids? Fraction that invent technology to communicate. Of the planets that develop intelligence, how many invent radio dishes, lasers, or other means to signal others? While filled with uncertainty, the Drake equation does highlight how even very conservative estimates can yield a sizable number of civilizations just in our galaxy. By playing with the variables, we get a sense of the odds, implications, and criticisms. However, the values of almost every term in the equation are open to debate based on our limited data sample of one. We only have a single technological radio-capable species to observe thus far, our own. The Drake equation shows that when we search the celestial depths for others like us, we may simply be seeking our own reflection in the cosmic mirror. There are also inherent anthropocentric biases. We assume aliens must be at least as communicative and curious as humans. Perhaps most technological civilizations are inward-looking or conceal themselves deliberately on a galactic scale, invalidating our assumptions. The equation shows how we have mastered quantifying the uncertain, but not eliminating it. The Great Filter. In 1998, economist Robin Hanson suggested the very silence we detect in what should be a teeming universe implies a great filter blocks civilizations from advancing to galactic scales. This evolutionary filter represents one or more steps speculated to be extremely unlikely to successfully pass through. Consider our 4 billion-year-old Earth. Basic, single-celled life arose fairly soon after the planet cooled, and robust ecosystems were well established just 500 million years later. Yet multicellular animals took over 3.5 billion years more to emerge. Complex tool users that could wonder about the stars? They only showed up in the last millionth of Earth's history. Perhaps the transitions from simple to complex life are great filters in themselves. What could the filters be? Here are some of the steps that theorists propose may constitute impassable filters. Assembly of reproductive molecules from inorganic compounds. Achieving that initial spark of reproducing chemistry could be rare. Transition of life from single-celled stage to multicellular creatures. Remaining single-celled for billions of years seems common. Making the leap to complex bodies built from specialized cells is not. Other major transitions like development of sexual reproduction, sight, flight, intelligence, each carry unknown improbabilities. Capability to communicate over interstellar distances, being able to signal or send probes beyond one's early planet-bound phase may be the rarest of feats. For a species to transcend its planet, all steps must succeed in sequence. If even one proves an insurmountable barrier, dreams of galactic expansion die. The disquieting corollary is that perhaps we ourselves haven't yet passed the great filters. Another unsettling implication is that even if simple life is common in our galaxy, we may be surrounded by planets trapped and isolated at primitive stages, unable to reach across the void. Perhaps Fermi's question has no single answer. The paths and barriers life must traverse are so complex that our models fail to capture alien intricacies. The void remains silent, and we find ourselves peering into an abyss. Enigmas like the Fermi Paradox, the Drake equation, and the unsettling Great Filter theory underscore how abundant our unsolved questions are when pondering alien life and our possible place in the universe. As we discover more exoplanets and improve our detection capabilities via missions like the James Webb Space Telescope, we may finally find signatures that confirm or refute our speculations over whether we are alone in the cosmos. Make no mistake, the answers could have profound implications on how we perceive our past and odds for our future. Discovery of even simple extraterrestrial organisms would tell us the genesis of life itself cannot be impossibly rare. Detection of signals from technological civilizations more advanced than ours would trigger a reassessment of assumptions humankind has held for millennia regarding our position in the cosmic order. For now, the quest continues to enthrall our imagination as we contemplate profound puzzles like whether we float on one speck of life amongst 100 billion lifeless worlds, or perhaps stand on the cusp of contacting minds unimaginably more advanced than ours. I invite you to further ponder and explore what these ideas evoke in you personally. Do you feel hopeful, unsettled, excited? And what might your reactions say about your perspectives on existence itself? The value in wrestling with such speculative concepts extends beyond facts. It pushes us to clarify our place amongst uncountable stars and our vision for our still unfolding future. The questions compel us to gaze within at our deepest assumptions just as much as we peer without towards the fathomless beyond.